Hey folks, welcome to my channel number 10. So there we have the problem on our screen. Find the derivative of the following y equal to tan inverse of cos x plus sin x the whole divided by cos x minus sin x, right? So this is a tan inverse problem and we have a cos and a sine inside the tan inverse, right? And like I discussed in my previous videos, our objective first will have to be reduce the expression inside tan inverse to a tan, right? So, I mean, we'll have to try and see if we can reduce it to a tan so that it simplifies our y, right? So I'm going to pull out the inner expression and let me call it, say, g, right? Now, if I want to bring in tan into this particular expression, you take a close look at this. If I divide the numerator and the denominator by a cos x, what do I get? I get a cos x plus sin x divided by cos x. And similarly, I have a cos x minus sin x divided by a cos x, right? So this way, I will be able to introduce my tan into this particular expression, right? And why is that? Now let's focus only on the numerator. My cos x plus sin x, the whole divided by sin x is nothing but a 1 plus tan x, right? And then my cos, I'm coming to the denominator, my cos x minus sin x, the whole divided by cos x is nothing but a 1 minus tan x, right? So I'm left with 1 plus tan x, the whole divided by 1 minus tan x, right? Here is where I want you to remember one more identity which comes in very handy whenever it comes to solving problems in trigonometry or solving problems in calculus using trigonometry, right? So my tan of a plus b is nothing but tan a plus tan b, a plus tan b divided by 1 minus tan A tan B, right? So this is an identity that is very useful for all of us to remember. And therefore, when I have an expression like this, right, 1 plus tan x divided by 1 minus tan x is 1 is nothing but tan of pi by 4. Tan of pi by 4 is nothing but 45 degrees. Tan of 45 degrees is your 1, right? So I'm replacing the 1 by tan pi by 4. And folks, I want you to draw a parallel to this particular formula, what I've written down here, right? Tan A plus tan B, the whole divided by 1 minus tan A tan B. And let me highlight it in green. And I'm trying to bring this particular expression to this tan a plus b format, right? And will I be able to do that? The answer is yes. And why is that? Because my tan pi by 4 is 1. So I write my tan x as tan pi by 4 into tan x because it doesn't change my expression. Now I have an expression of the format tan a plus tan b, the whole divided by 1 minus tan a tan b. And what is my a and b? My a and b is nothing but x and pi by 4, right? So I'm left with g equals tan of x plus pi by 4. And now you see I have a tan inverse problem, and the expression inside the tan inverse I have been able to bring it to tan of an expression, right? Because a tan inverse of a tan is nothing but the expression inside tan, right? I hope you're following me. So tan inverse of tan theta is nothing but theta. So whatever you have in place of theta, for example, you have tan inverse of, say, tan 3x, then it's nothing but 3x, right? So y, I'm just going to go back to my y because now that we've done the simplification of g, I have my y as tan inverse of tan of x plus pi by 4, right? And what is that? That is nothing but x plus pi by 4, right? So now you see my y is nothing but a very simple expression, x plus pi by 4, and therefore my dy by dx equals 1 plus d by dx of pi by 4, which is a 0, right? So my dy by dx equals 1. So that's how we go about solving this particular problem, right? I hope you found this content useful. Please do subscribe to my channel and support. Thank you.